Hello, everybody. Good evening. Dear authors and invited guests, I welcome you all to Technical Session 6D. Myself, Sirali Gaur, and this session would be moderated by me. On behalf of Global Knowledge Research Foundation and GS Scholastic, it is my great pleasure to welcome you to the 11th International Conference on Information Communications Technology for Sustainable Development, ICT4SD 2026, Goa, India. The 11th edition of the conference is being organized in a hybrid mode. The physical event is being held today, on 9th of July 2026 in Goa, India. The virtual event is being held through Zoom from 9 to 11th July 2026. I really hope you will enjoy this knowledgeable and interactive session throughout the day. In this session, we have a total of 10 presentations. Each presenter will be given 10 minutes for their presentation, 2 minutes for question and answers, and on the 9-minute mark, I will raise a gentle reminder. There is another request to all the participants that you stay connected with us till the closing remarks. If you have any queries or any updates, feel free to write to me in the chat box. Just before we start the session, I would like to introduce you all to the chair of this session. Dr. Kiriti Vanjale is a professor in the Department of Computer Science in Vishwakarma Institute of Information Technology, Pune, India. With 22 plus years of distinguished experience in engineering education, she manages high impact academic quality frameworks alongside active research portfolios in emerging computing architectures. Her expertise focus on wireless sensor networking, artificial intelligence models, IoT applications, and computational image processing. Now, let's start with the papers. Our first paper is by Preetham Saha with the paper title A Digital Twin Framework for Smart Agriculture Context, Aware Anomaly Detection Using LSTM Autoencoders. Dear presenter, you may start presenting.
Yeah, sure. Yeah, hope my screen is visible.
Yes.
Okay. So, hello everyone. My name is Preetham Shah from Indian Institute of Technology, Dhanbad. Today I am presenting our research on digital twin framework for smart agriculture, specifically focusing on context-aware anomaly detection using LSTM autoencoders. In today's scenario, smart agriculture has been a prime interest for researchers, which includes rapid adoption of IoT, which generates a massive influx of data, and our current systems fails to translate it into actionable insights. The main reasons for this to happen are the data generated are disconnected simply without any visualization. They look like simple data points, and that's why critical issues are only identified after they have already caused significant damage. Also, the traditional anomaly detection models rely on thresholds, which do not change with the biological cycles. For example, let's say in Indian climate, a temperature of 14 degrees is normal in midnight. But if that same temperature is shown during 2 p.m., then it may refer to some critical heating failure. To solve this, our research has three main objectives. First, to design a novel digital twin framework, linking spatial virtualization in Azure with deep learning. Second is to conduct a comparative analysis of 5 anomaly detection models. And finally, to validate the superiority of an LSTM autoencoder approach. Our proposed architecture consists of two layers. The data acquisition layer utilized Azure IoT Hub to continuously stream data from physical sensors into their virtual counterpart within the Azure Digital Twin. Then this feeds our analytics layer, where LSTM autoencoder evaluates the data and flags its anomaly or not. If there is an anomaly, then it creates an alert, which is visualized in the real-time command dashboard. We validated this framework on two real-world datasets, which are uh, a 122-day greenhouse dataset, and a 9-year open field soil moisture dataset. The data was normalized using mean max normalization. Missing values were replaced with nearby points. And for our sequential models, the data was split into 80-20 train validation ratio. To test our framework, we designed a comparative study. First, we looked at clustering models like k-means, dbscan. The core problem with this is that they flatten the data. They group points by spatial density and completely ignore the importance of time. In farming, this makes them context blind. They cannot tell the difference between a normal midnight temperature drop and a heating failure. To solve this, we evaluated sequential models, specifically LSTM and LSTM autoencoder. Unlike clustering, these models are use continuous time windows to learn the actual biological and seasonal cycles of the farm. We trained our autoencoder entirely on normal data. When it sees an unfamiliar or anomalous sequence, it fails to reconstruct it. And that spike in error acts as our digital twin alert. Now, these are the results of how they have performed. As you can see, the clustering model struggled. The single linkage clustering flagged over 1,000 anomalies, while dbscan was overly conservative and found only 45. However, our LSTM autoencoder successfully isolated 119 anomalies with lower training and validation loss. Now, if we visualize this, the failure of traditional clustering is obvious. K-means and hierarchical clustering, they generate massive clusters from normal daytime variations. They also basically accept a heating failure or like high CO2 levels as a normal operational value. On the other hand, our LSTMs perfectly tracked the contextual shape of the data. As you can see in these graphs, they ignored the normal temperature shifts and isolated the anomalies without overfitting. To prove this works in the real world, we deployed the optimized autoencoder onto Microsoft Azure. We mapped our physical farm into a digital twin graph, linking the sensors. To make this output actionable, we built the farm command center dashboard. It constantly reads the digital twin and translates the complex anomaly scores into simple visual trends for the farm operators. To recap our discussion, clustering models are far too incompatible for agriculture because of the temporal blindness. Our research proves that the LSTM autoencoder is vastly superior because it evaluates the importance of the entire time window. By deploying this intelligence on Azure, we successfully created a system that delivers real-time actionable insights directly to the stakeholders. Ultimately, this framework bridges a critical gap by combining digital twins and deep learning. The key takeaway is that sequential pattern recognition is absolutely mandatory for detecting time-dependent anomalies. Moving forward, we can push this intelligence to edge computing devices to keep the farms autonomous during network outages. Also, we can integrate federated learning so that neighboring farms can collaboratively adapt to the climate shifts while preserving their data privacy. And these are all the references we have used in this research. Thank you.
Thank you so much for your presentation. Do we have any questions? Okay, you may stop presenting.
Okay, thank you.
Moving forward, we have Faguni Jha with the paper title A Review of Digital Tools for Resolution of Disputes in Construction Project Management. Presenter, you may start presenting. Okay. Next, we have Jennifer Flores with the paper title Bibliometric Analysis of Research on Life Cycle Assessment Applied to Board Recycling and its Environmental Implication as an Approach for the Education Context. Eudic- Eude- Euclidean context. Sorry. Next, we have SSKS Anirudh with the paper title Hybrid Quantum Classical Deep Learning for High Fidelity Medical Image Compression Across CT, Breast, and Knee Modalities. Presenter, you may start presenting.
Hello, hello. Can you hear me?
Yes.
Yeah. Good morning, ma'am. No, one second, ma'am. I'm sharing my screen.
Yeah, sure.
Ma'am, is it visible, ma'am?
Yes, it's visible, sir.
Good morning, ma'am. Today I'm going to present my paper on hybrid quantum classical neural networks for medical image compression and diagnosis. And we did this under the guidance of our professor, Mr. R. Sai Venkat, and my fellow teammates, Vritika and Yatin. So basically, our paper is about medical image compression, and we used CT scan and breast images and knee X-rays for as a data set. And this works. This work introduces quantum compress and parameterized quantum circuit (PQC), and also unit encoder decoder architecture to achieve near lossless compression with 87.5 storage reduction. The quantum component extracts important features using angle encoding entanglement simulation. A novel QPA mechanism also involved in this. This model is highly trained for edge preservation accuracy and to increase the image quality. And the SSIM and PSNR values across the CT, breast, and knee are effective and efficient solution for medical image compression. Uh, to introduce our project, we took huge volumes of medical image data from hospitals and some data from Kaggle, and we also compressed it, uh, and then we used deep learning autoencoders to improve the quality and to ensure smooth efficiency and very high compression ratios. We proposed HQ compressor hybrid quantum classical model for high fidelity medical image compression. So basically, our problem statement is medical images carry tiny grayscale details that decide the diagnosis, but usually those details when normal compressors compress it, those details usually miss. So by using quantum computing, we and deep learning, we basically um, do not miss those minute details. Uh, there is a strong need for a compression that saves large storage space also without losing these minute details. So our hybrid quantum model does both of this. The major modules are data ingestion and pre-processing, recursive scan for PNG, JPG, PMP, TIF. We also use GIF, which we didn't mention here, for across CT, knee, and breast data sets. The grayscale conversion, we have mentioned it as 256. We can normalize it. And quantum feature map, angle encoding theta is equal to pi sigmoid, maps pixel values is equal to qubit rotation angles. Basically, the pixels we convert it to angles and then we decode it and then we decompress it and make it size less. Quantum phase attention, channel attention, as you can see here, alpha is equal to cos square using Bond rule. In hybrid unit encoder decoder, super resolution definer, hybrid loss function, class web application. So we made a web application through which we can upload the image and it shows the results. So we do not need the terminal and all. We basically automated it. These are the data we have collected from Kaggle, CT scans and EX-rays and breast images. This is the architecture of our project. The input image is 256 into 256 grayscale. Then we normalize it in the gray. We normalize it, and then we do angle encoding, and then angle entanglement, and then we use the bond rule as mentioned earlier, and then we have the bottleneck encoder decoder structure. Before that, we see encoder 1, encoder 2, encoder 3, and encoder 4. After that, bottleneck, and then decoder 1, decoder 2, decoder 3, and then the refiner. And then we get the reconstructed image where we can evaluate it by using PSNR and SSIM evaluation. We also mentioned the CT scan also. CT scan, it has 54.46 dB and knee has 49.69 dB and breast has 46.04 dB. Whereas SSIM score is 0.9997 and for knee X-ray it is 0.991 and for breast it's 0.9961, which is actually better than our base paper. This is the implementation which we have done as mentioned earlier. CT scan, breast scan and X-ray, and we can upload the image here and we can also download the results which with the PSNR and SSIM scores. These are the training metrics which we have done by NumPy and visualization packages. The proposed HQ composer, a hybrid quantum classical deep learning framework for fidelity in medical image compression across the inputs we have used. The simulated parameterized quantum circuit with 8 qubits and 824 parameters encodes image features into quantum Hilbert space using angle encoding and ZZ entanglement. The fixed 8 into 32 into 32 latent bottleneck achieves a constant 87.5 storage direction per image across all modalities. And four component hybrid laws MSC, mean square error, SSIM, and solve latent entropy ensures structure edges and pixel fidelity. The future scope for this is we can extend to 3D CT volumes and add a perceptual loss term and develop a unified multi-model to handle all image modalities in a single architecture. And we can also add LLMs into a local LLMs into it so it can answer basic doubts about the diseases and role-based access also we can put into it so only hospitals or patients we can you know give some roles and they can access only some part of it and then extend the framework into joint compression and diagnosis pipeline for automated disease prediction and port the quantum circuit to real NSIQ device using Qiskit. These are the references we have mm, to make this. Thank you. Any question?
Thank you so much. Do we have any questions? Okay. You may stop presenting now.
Thank you, ma'am.
Thank you.
May I leave, ma'am?
Please stay with us till the closing remarks.
Okay, ma'am.
Moving forward, we have Devashi Sharma with the paper title IntelliStake, an AI governed crowd venture investment platform for all Indian retail investors.
Yeah, just a second. Let me share the screen.
Okay, so
Is my screen visible?
yes, sir.
Yeah, so I will start the presentation. So our presentation title is IntelliStake, an AI-governed crowd venture platform. So in India, if you want to invest in a promising startup, the legal way you need to invest at least a 1 CR through an AIF that logs around, let's say, 150 million retail investor completely. And even if that money but didn't exist, there is no public tool that can give us the trust score for the startups. So we have used RAISE for it. RAISE is basically risk, AI, investment, security, and escrow. So COEX survival is a math model used to predict the lifespan of a startup. Like how will it, what is the lifespan of a startup, that it will go bankrupt or it will not go. And anomaly detection is basically it will detect what are anomalies in the data. uh, for AI, we have used tagged ensemble. It will take the voting from different AI and give us a combined voting system from stack ensemble. And Shap will explain why it is happening. So it is not a complete black box. For investment, we have used Black Letterman model and Monte Carlo. These are the model which also hedge funds use. For security, we have used ERC 3643 for KYC, identity registry, and compliance rules also. And we have used a blockchain like for it. And escrow, we have used milestone escrow for that. These are the five engine working in concept. Data injection. So we have used 107,190 startup records, 46,809 funding codes and MCA filing, GitHub signals, and RSS newsfeed. NLP enrichment is all mini LM L6 V2 368 dimensional. So what will it do? The big sentence, it will convert it into 384 dimension embedding without losing the meaning, and PCA will convert it into 8 dimension without losing the meaning of the sentence. So it will give us the fast answer. Stack ensemble, we have used XGBoost, Lice BGM, Cat Boost, and Tab MLM. And combining that Bayesian meta learning will give us one trust score for the startup. Risk score, we has used Cox PX, Isolation Forest, LOF, DBScan, Autoencoder. These four model are anomaly voting encoder, and portfolio we have used Black Letterman and Monte Carlo, which have given us Sharp of 1.34 and Sorrento also. So these Sharp and Sorrento are basically uh, risk per unit what we got. So these are the 29 features which we have put, and AUC ROC which we got is 0.915, which is pretty good. And median AP is 66.5, which sound to be like very high, but as you see the venture capital analysts are, according to studies, are mostly 65% wrong. So we have achieved 66.5, which is pretty good, and sharp narrative is 500. When the startup falls around the trust score 0.35, we freeze the funds of the startup. So this is the Black Letterman formula. This seems to be like a pretty complex formula, but it is not. It is just the market opinion and what the AI view gives us. So it will give Black Letterman score based on this, and Monte Carlo we have taken 10,000 paths. So these are the results across three investor profile: conservative, moderative, aggressive. So in conservative, the expected return is basically 12 to 15%, but the 5 time we can lose around 8.2% of the money. In moderate, the expected return is 18 to 24%, but VAR is 95, so 5 time we can lose 15.4% of money. And also, just a second. And in aggressive, the expected return is 28 to 38%, but VAR is, let's say, 5 time we can lose 24.7% of our money. These are the smart contract. We have actually taken 6 of them. Identity register. We have used ERC 364 for this KYC. So it will be like in 3 investor tiers: retail, institutional, and accidental. And IntelliState tokens, this we will give to the startups, like if they are registered and we know that they are real, so we will give them IntelliState tokens. Milestone escrow is basically the startup that they claim achieving the goals, then the milestone escrow will give them the trust score. If the trust score goes beyond 0.35, so the money will be freeze. Trust Oracle is basically SCAN signed trust from off-chain ML and CROW verified. The compliance rule is enforce investment cap, transfer sector limits. These are the summary of what we have done. AUC ROC is 0.915. AUC lift is 39.6 pp. Median AP is 66.5. Professional venture capital was 65%. Cox PSC index is 0.71, which is pretty good from 0 to 1 range. Sharp ratio is 1.34. Sorrento ratio is 1.89. And Oracle sign match is also 100%. That means all the smart contracts are working properly, and startup records are 1,08,000 around. Thank you.
Does anyone have any questions regarding the same? I can answer them on his behalf as well.
Thank you. Any questions? There's a question in the chat box. How does the platform calculate a startup's value?
So basically, we have taken a lot of records from MCA filings as well as through Crunchbase and Kaggle. But the thing is that for every startup, a newly launched startup, the data is very inaccessible, actually. So what we have done is used an AI and used the company's financial records. We have trained multi-modular setup where we have calculated different models and metrics to understand how the BSC, SME, and NSC emerges the disclosures for the company as well as for the startups valuation. We have also used some companies that have already been listed publicly, such as Zomato or Zepto, whichever have been recently launched. So then comparing to that metrics and comparing to the online model, which we have trained using financial models as well, so which we get a nearest trust score. So basically, given that trust score, we can measure how well our estimation is compared to the startup. So if a startup is poorly performing, basically given on our records or on our system, we can mark that at we can mark it as this is not a good investment for the client. So basically what we are trying to do in this project is that this is a AI governed platform that will help you invest into startups without getting your money stuck from the start until like for like 6 to 7 years. Basically that's how long it takes for a startup to grow. So what we have done here is added a blockchain part that will you help us to invest our money in phases. So basically during the launch, our investors can invest into a company or a startup at basically given 25% of the fund only at the start. And then as the fund grows or the startup grows, the next 50% will be sent to the company or startup itself. And if the startup fails to meet its promises or the promised growth as well, our model can give you a signal or something like that, an indication that can tell you that the promised benchmarks haven't been met, and so then the blockchain part can pull back your money from the invested startup and maybe give you a safer position in the market as well. So not a lot of money will get stuck, and you can have an AI model that will do basically everything for you on its own. That's the main punchline.
Okay,
Any other questions?
thank you.
Yeah.
Next, we have Prerna NS with the paper title Money Mule Detector, a graph powered AML investigation platform.
Am I audible?
Yeah, presenter, you can start presenting.
Okay. May I know if it's visible?
Yes, it's visible.
Good afternoon, everyone. My name is Prerna, pursuing engineering in the Department of Computer Science from the College Dayanand Sagar Academy of Technology and Management. So, today I am presenting a project titled Money Mule Detector, a graph-powered AML investigation platform. So, let us see with the introduction first. So, what is Money Mule? A money mule is basically a human bridge used by the criminals to launder the money. So criminals can't just transfer stolen funds directly into their own bank account because it leaves a digital trail straight to them. So instead, we trick or to recruit someone else to use their account to move the money. Okay. So the problem statement defines, let us see with this with a real world example as well. So suppose there is a college student who is looking for the extra income, applies for a job, which is listed in the LinkedIn titled data entry specialist. The employer says our company has international clients. They will transfer payments to your personal bank account. You just need to keep 10% as your commission, withdraw the rest in the cash, deposit it into our main branch, means the employer's main branch. Okay. So basically what here happened is a student has just helped to hide the criminal's track. So the criminal uses multiple ways. There are patterns as well. Let us look. Okay. There are patterns as well. There are smurfing, layering, and shell. Shell is basically a company which is neutral, and smurfing, getting the stolen cash into the system.
Sorry to interrupt, but your slides aren't changing.
Is it not changing?
No, it's still the first slide.
Okay, wait. Now?
Yes, now it has changed.
Uh, should I start from the begin or should I continue?
No, you can continue.
Okay. Okay, there are three patterns: smurfing, layering, and shell accounts. So shell is basically a company which is neutral. So smurfing, which means the getting the stolen cash into the system directly. Basically, what criminal does is he breaks or splits the money. Suppose there is 1,000 rupees, he splits the money among the 5 peoples, 2,000 per head. Yeah. Then he deposits the money to their bank accounts. So he uses this method to hide his tracks. And there is a layering as well, which the hiding the trail. So basically, it's a complex web transactions changing its forms. Goal is to build so many layers, and it usually shuffles. So it is difficult to identify the actual fraud happened in the money mule whole thing. So this platform we have built for the investigators. So we have used graph neural networks to identify and detect multi-hop money networks and layering topologies. And for the storing data, we have used Neo4j for the temporal windowing, and which captures the exact chronological transaction sequence and reduces the false positives. So also we have used the explainable AI, which explains the explainable AI translates abstract algorithmic calculations into the real visual evidence, such as rendering graph attention weights on the canvas. This is the example, which is necessary to fulfill global regulatory compliance audits. And also, to implement the predictive analysis that forecast network evolution and preemptively to accounts at the risk of recruitment. Also, we have deployed the self-healing CI/CD pipelines that continuously monitors and correct the time with a data drift. So let us look at the literature survey. So in year 2026, it was mainly focusing on the awareness rather than detection. So they have not used the AI more in this. So in our case, we have used the AI and ML, GNN networks, deep learn. Yeah, models also have been used in our project to reduce the bottlenecks and to detect the hidden fraud networks in the suspicious transactions happen in the real time. And also to reduce the false positives, it filters out the harmless high volume transactions and cross-reference initial anomaly flags with graph algorithms to ensure the account is actively participating in the suspicious structures like layering rings. So in the year 2025, there was a high computation cost and memory bottlenecks. So we have wrote the data harvester script to reduce those bottlenecks. And in the 2025, there was an overhead in the visualization for the investigation, and there was a lack of tools as well. So we have a better visualization for the investigations to investigate. In the year 2024, there was a like if there suppose as I told earlier, there is a pattern called layering which hides, but this in the 2024 year there was a gap which they cannot find the complex multi-hop accounts. So our project overcomes this gap also. In the 2024 again, there was a limitation in yeah, there was a limitation in this blockchain as well. They have implemented, but not as which is useful for the users to efficiently use it. So to make our tool code ready, we implemented a cryptographic ledger which is linked to the SHA-256 hashing. Every time an investigation marks has an account has fraud, the system generates a block. This block contains the account ID, the evidence hash, a timestamp, and the previous block hash also. So next, methodology. So let us see how it works. So in the real-time money mule detection and financial crime investigation platform, we ingest a raw transaction CSV files, convert them into the directed graph, and applies graph theoretic fraud detection and visualizes the suspicious networks. So for before it is being converted to the directed graph, SHA-256 hashing for the encryption of accounts is done, and for the graph construction, network X Johnson's algorithm is used, which is a graph theory engine for the directed graphs. Next, yeah, this is the flow of how the project works. So first here we upload the CSV document, and pandas which are used to read CSV and group transactions by the sender and the receiver, calculates the total amounts in the pandas, and it constructs the graph construction networks, and it detects the patterns, morphing, layering, and shells accounts. And then we can also download the AML report as well. Next.
Sorry, presenter, you are still on slide number 6. Yeah.
So yeah, this is the architecture, how it works. So here we upload the data, and as I told earlier, pandas which reads the CSV and groups transactions by sender and receiver and calculates the total amount, and the graph is being constructed here, directed graph, using the network X algorithm, and the pattern detection, smurfing, layering, and shells is being done here. We are using breadth first search analysis for this, and we can also generate the AML report. So software requirements, operating system, Ubuntu or Linux, Windows or Mac OS. For programming language, we have used Python and JavaScript. For frontend, React.js, Node.js, and Cytoscape.js. For backend, Fast API, because it's perfect for the data pipelines. Fast post, analyze, and accept CSV returns and JSON. And for database, Neo4j graph database. And for AIML libraries, we have used PyTorch geometric, and explainable AI, we have used Sharp, and for deployment, Docker and Git. Let us see the results. Okay. This is the home page where we can see the latest AML news and the latest laws and analysis, and also search for the databases. And this is the way the dataset is being ingested. We have used the PaySim dataset, which is a synthetic dataset based on the real financial logs from the money mobile service in Africa. Since it's massive and contains 6.3 millions of transactions, uploading would crash. So we have wrote the data harvester script here. So the total transaction is 2081, and accounts are 3928. And the suspicious that are found is 85. Smurfing is 79, and layering cycles found is 2, and shell accounts are none. So this is a syndicate view, means the overall view of the transactions from the data set. And we can also see the isolated view as well. So in the isolated view, we can notice here there is a layering cycle is formed in here. So layering is basically, as I told, it hides the trail, like complex web of transactions. So we cannot find actually how and when it has been transacted. So we can click the node and we can mark it as fraud or safe. So basically this layer formed is a fraud. So we can mark it as a fraud. Yeah, and that is being stored in the audit chain as a block 1 and block 2, and the session ID and hashing is done using the SHA-256 hashing. And yeah, the accounts that are being marked safe fraud are listed here, and we have a AI chatbot as well. And if any queries or anything suspicious if we found, we can just mail them. So yeah. And future scope, we are implementing real-time temporal modeling and cross-institutional ledgers and also advanced explainable AI. So yeah, thank you.
Thank you so much for the presentation. Do we have any questions from anyone? So there's a question in the chat box. Could future work incorporate life cycle assessment, LCA, carbon footprint analysis, and economic cost benefit evaluation to strengthen the procurement framework?
Is the question in the chat box?
Yeah, it's in the
Can
chat
you
box.
repeat it?
You can stop presenting.
Okay.
Could future work incorporate life cycle assessment, LCA, carbon footprint analysis, and economic cost benefit evaluation to strengthen the procurement framework?
Yeah. Just a moment. So, while the current focus is primarily on the algorithmic detection accuracy of financial crime syndicates, extending this into a sustainable engineering is highly valuable. In the future work, we can absolutely incorporate a life cycle assessment and carbon footprint analysis. Yeah. Regarding that, heavy cloud compute infrastructure require a deep graph models and blockchain validation nodes. So we can yeah, we can do it.
Okay, thank you so much.
Thank you.
Moving forward, now we have Sarthak Mandape with the paper title Privacy Preserving Biometric Payments, a lightweight homomorphic encryption framework for edge cloud architectures.
Hello. Just I'll present my screen.
Yes.
Yes. Yes. Is it visible?
Uh, yes.
Yes. So hello everyone. I'm Sarthak Manpe from Marathwada Mitra Mandal College of Engineering, Pune. So today I'm here to present a paper, Privacy Preserving Biometric Payments, a lightweight homomorphic encryption framework for edge cloud architecture. So we are proposing this system for the IoT devices and the payment system. So nowadays fingerprint authentication is used in various payment systems. So we were developing an application where the payments would be done using the fingerprint instead of the OTPs and pins. So as to overcome that, the main problem is the biometric data is exposed. So if the pins, passwords, and OTPs are can be phished and they can be stolen from the cloud or anything. So database breaches can happen and the data can be lost. So the main problem was about the privacy of the user. So as to overcome it, we have proposed this solution, that is the homomorphic encryption. So what does homomorphic encryption means? The encryption and the decryption of the text is done over the encrypted text only. So means the data of the user is not leaked at any point. So there are multiple homomorphic encryption techniques. such as the PHE, that is the Pallier homographic encryption. So that supports only the addition operation for the encryption. Then there is the SHE. So it supports addition and multiplication, and it is used only for the integer values, and it is used for some limited number of operations like that. Then there is the CKKS, so that is used for the floating point integers, and then there is the FHE. So it is also used for everything. So in from this we have used the BFV scheme, that is the Brecker skip and Verkauter and BFV scheme. So we have proposed this for AS608 IoT device, that is the fingerprint sensor. So as the BFV supports the exact integer arithmetic operations. It supports addition, subtraction, and multiplication operations. These three operations are supported by BFV and for integer arithmetic operation. So it avoids the bootstrapping also. So bootstrapping is used for the noise reduction. So that is avoided. So this is a proposed system architecture. So there is in the BFE, there is the main is public key, secret key, and the evaluation keys are there. So the public key is used for the encryption purpose. So when the user registers over the AS608, so there is first is the registration process, and then there will be the verification, that is the payment system. So when the user registers it on the edge device, that is the AS608, that will be encrypted using the BFV scheme, and it will be stored onto the cloud. So once and the cloud will show the encrypted data, and the secret key that is will be the on the user side. So once it is stored on the cloud, then on the next time when the user comes for the payment system or the verification again, so his live fingerprint will be captured, and that will be again encrypted. So the comparison will be done on the encrypted only. So its template stored over the cloud, and the live fingerprint will be compared. So based on the threshold, if it is below that threshold, then it will be matched and the payment will be successful. If it's not, then it will not be successful. So like that, our system architecture is proposed. So for the authorization purpose, we have designed this. Then it consists of three operational phases. First is the enrollment. The enrollment will be done on the AS608. Then the matching will be done over the cloud it calculates using the Euclidean distance, that is the registered fingerprint and the live fingerprint we are currently taking. And then the authorization. The authorization means we have means it returns us the distance, that is the threshold value, and depending on the threshold value, we do the authentication or authorization of the user like this. So the feature extraction means when the fingerprint is registered, its feature vector is constructed by calculating its regions and binarization, and everything is done over it, and then it is stored over to the cloud using the BFV encryption scheme. Yes. So main purpose of this is for the security analysis, because the fingerprint data is too sensitive, and if it is lost or breached, then it would cause a chaos. So anti-spoofing is done, then template protection. The template protection, only the encrypted templates are stored over the cloud. The cloud cannot see anytime uh, the original data what we have stored. That is the template protection. Then replay and inference attack. So encrypted data cannot be reused for without valid keys. The secret keys which we are using, it cannot be used there. Yes. So for this, so this is the computational latency based on the ESP32 we have used. So these are just the estimated values which are means derived using the computational complexity and the hardware complexity. The minutiae extraction is there, that would take about 300 milliseconds. Then feature encoding, like encoding into the vector. Then encryption is there, and then cloud homomorphic morphization and decryption. So overall, around the 8 means 1 second to 1.5 second would take for this entire process. So that is comparatively lesser than other PIN and passwords. So this one is this. Yes. So these are multiple homographic technique, which we have done the research and selected that we can go with the BFV one. So as I earlier said, PHE is there, which supports only addition. And SHE is there, addition and multiplication are supported, and it works with all the integers. Then there is CKKS, which is used for addition plus multiplication, and it gives approximate results. Then there is the FHE, which requires the bootstrapping. So bootstrapping is nothing but the noises included at the each step. So as to reduce that noise and that ciphertext to be readable means used after all means multiple operations, bootstrapping is required in the FH. Whereas in BFE, bootstrapping is not required as it already reduces only some amount of noise. So that is the one. And there is a hybrid HE, which combines the PHE and the BFE. Yes. So conclusion and future work. So currently we have developed a prototype using the ESP32 AS608, but it is currently on the local machine. So as to store it over the cloud, so we have done all this research and come with a solution that we can go with the BFV scheme. So we are going to try to use this in our application, which is currently there, prototype. So yes, that's all from my side.
Thank you. Does anyone have any questions?
Thank you.
Okay. Moving forward, we have Jyoti Banerjee with the paper title Smart Sustainable Farming Using Internet of Things, Cloud Computing and Big Data.
Hello. Am I audible?
Yes. Presenter, you may start presenting.
Okay. Now visible? Screen visible?
Not yet, sir.
Okay, now
No, sir.
not visible.
No.
Screen share, can you hear? Screen share, screen. You are visible, ma'am?
No, the screen is not presenting.
Voice is not coming close. Yes. Now visible, ma'am?
No, sir.
Just a minute, ma'am.
No problem, sir.
Okay, just a minute, ma'am. The screen visible कर दो ये आ जाए. क्या है? हाँ, DC कर दो. हाँ, ये. Share. Yeah. Now, okay, ma'am?
Yes, it's visible now.
Okay, thank you, ma'am. Okay. My topic is smart sustainable farming using IoT, cloud computing, and the big data. Now, the abstract of this topic is that in this case, in smart farming, we have now in this time we have used the IoT, cloud computing, and the big data. But smart farming means that now in previous we are using the traditional farming, but now in this times with the help of the IoT, cloud, and big data, we are using the smart farming. Smart farming just means that to use the IoT, cloud, and the big data. In smart farming, first point is that the traditional farming faces challenges of productivity and sustainability. In previous case, in traditional farming, we are just using the previous method for the farming, but now in this times, main point is the sustainability. Sustainability just means that to use the renewable energy. Now I will explain it one by one. In forward slide. The slide highlights why smart farming is important. Smart farming is important for now in this time we have the lack of time. We want to use the new technology, so we are using the smart farming. The importance of the smart farming is that the improve the crop yield and farm efficiency, means that the reduce wastage of water, fertilizers and pesticides, enhance sustainability and reduce labor dependency. Means that with the help of the technology, now in this time we are using the smart farming. Now, next one is the IoT in agriculture. In this time, in all applications, we are using IoT, cloud computing, and the big data. IoT just means that with the help of the sensors, with the help of the drone systems, we are using the we are using in case of the agriculture. Also, we are using in healthcare in every other systems also. Audi connects physical farming devices through sensors and networks. Farmers can monitor crop conduct remotely. Means that with the help of the Audi devices means the drone systems and GES systems, GPS systems we are using in case of the agriculture. We are using precision irrigation monitoring. Now, what is the precision? I will explain it. IoT smart agriculture involves gathering data on facts like weather, humidity. Means that in case of IoT, we are using the devices as sensors, as drones, and in cloud computing, we store the data in cloud to access the data with the help of the cloud monitoring. And big data means that the to store the data in the large amount. Now, one by one, we will explain IoT sensors. In case IoT sensors, optical sensor analyze soil quality and organic matter. In case of agriculture, now in this time, the soil quality to check the soil quality and to check the organic matters, we are using these sensors. Second one is the electrochemical sensor measures soil pH value and nutrition value. In traditional farming, farmers are have no idea about all these. But now in this case of the smart farmings, with the help of the IoT devices, we will find the pH value and the nutrition value. Also, moisture sensor and the irrigation needs. For the purpose of the irrigations, what is the moistures, what is the temperatures, we have find with the help of the IoT sensor. The IoT sensor plays an important role in smart farming. Now, next one, integration of IoT. In this integration of IoT just means that the in smart farming we have the AI methods and analysis after the finding value with the help of the AI methods. Smart irrigation activity, farm data provide planning and productivity. All are used in case of smart farming. How the integration means that the to combine the sensor, AI, and automata and the or other methods and reduce the wastage and help farmers make better decisions. Now, what's the benefit to use the IoT? To use the IoT devices, real-time monitoring of crops. In this case, real-time monitoring of crops. Use the this is the benefits of IoT. Real-time monitoring. Real-time monitoring means that with the of the GPS, global position systems and GIS and geographical information systems, we have used the real-time monitoring systems. Reduce waste and increase efficiency. We have reduced waste because sustainability means that the to recycling of the data, to recycling the waste materials. This is the case of the reduced wastage. Second, risk reduction through automated detection. In this case, we are using the AI method, so the risk will be reduced in this case in the smart farming. How do benefit agriculture by enabling real-time crop monitoring, reducing resource wastage, improve efficiency, and increase productivity through early problem detection. This is the benefit of the IoT. Now, what is the challenge? After the using of the IoT devices, we are also challenged high setup cost and infrastructure needs. In the case of in the case of the smart farming, we are using the high setup cost. Means that the IoT devices, as the cost of the drone is very costly, and the other devices are very costly. So high setup cost. This is the main point to challenge it for the poor farmers and infrastructure need. Also, we have need the infrastructure as we have a knowledge of the technology, how we have used the GPS system, how we have used the GIS systems. Second one is the connectivity and signal interferences. Also, we know that with the help of the internet, we will do the smart farming. So connectivity is also one of the main points in this case. Second, third one, the data security and interoperability concern. Data security is also one of the major points that because all the data is stored in a cloud. So cloud security also we have used the also we have knowledge of the how we will use the cyber security. So with the help of cyber security, we will secure the data. This is the main point of the smart farming. Now, third one, the cloud computing in agriculture. Because in smart farming, we have used the internet, we have used the IoT, cloud, and big data. First one, IoT is completed. Now, cloud computing stores agriculture data securely. In case of cloud, we have used the all the data in a cloud. So, in smart farming, cloud also play an important role. Second one is the real-time machine learning analysis. In this case, all we have used the IoT devices, so we have knowledge of the machine learning method in a real time. Third one is the improved scalability and accessibility. Now, in this case, in cloud computing, we have a fully knowledge of the how we will store the data in a cloud. Cloud computing helps farmers store and analyze agriculture data in real time. Now, next, cloud service model. Now, in this case of cloud service model, basically we have three types of model: infrastructure as a service. Number second one is the platform as a service. Number third one is the software as a service. With the help of the infrastructure as a service, we use the servers. Now, second one is the platform as a service. We give the applications for storing the data, and software as a service we use the software. So this slide explains cloud service infrastructure as a service provide infrastructure platform as the application development and software as the agriculture data in online. Now, what is the applications of cloud? Basically, these are the main points: precision farming, livestock monitoring, and the food traceability and the supply chain management. These are the three main applications of the cloud. Precision farming. Precision farming just means that to use the IoT, devices in the precision farming. Livestock method means that the now I will explain it one by one. Livestock method then means that the for this is also in livestock methods in livestock monitoring animals husbandry. We have used the animals husbandry and food traceability just means that the to transfer the data, to transfer the data from the farm to the persons is come into the case of the food traceability. Now, big data analytics means that in case of big data analysis, weather analysis, rainfall, and fertilizer trends also come helps in accurate crop predictions and third one the improved planning and decision making. Because big data just means that to store the large amount of data, so all the data easily we can store in the case of the big data analytics. Big data analytics help farmers analyze weather, soil, crop-related data. Now, benefits of big data increase productivity and forecasting, optimize machine and pesticides, or reduce food wastage globally. Now, come to the point of the precision farming. As we have discussed in previous slides, precision farming just means that they use the GPS system and GIS system. GPS system, global positioning system, and GIS, geographic information systems. Drone sensors, all we have used in the category precision farming. Second one is the allow site-specific crop monitoring. Now, with the help of the software applications from remote, we can easily monitor the specific crop sections. Third is the support smart irrigation. Now, with the help of the IoT devices, we will install the support smart irrigation systems. Now, third one is the precision farming. This is the case of the precision farming. Now, second one is
Dear
the smart.
presenter,
Ma'am?
I'm so sorry to interrupt, but you have crossed the 9-minute mark. Please conclude your presentation,
Oh,
sir.
okay, yes, ma'am, just conclude. Yeah. Smart farming framework. Smart farming just framework just means that from the traditional method we have go to the mechanist method, then intelligent method, and the digital agriculture. I mean that from the traditional to the digital agriculture. This is the case of the smart farming frameworks. Now, technology, just I discussed GPS, GIS, and remote sensing. Sustainability, there are three types of sustainability. Sustainability means that the renewal of the energy. Ecological sustainability is the resources, social sustainability, quality of life, and economic sustainability to ensure profitability. Now, challenges and future scope. The one of the main challenges of using smart farming is that the disease predictions. Now, in this time, we have means that these sensors are not so powerful that they can easily detect the predictions, means that they can predict the diseases of the plants. So this is the case. Harmoponic and vertical farming also challenge harmoponic, means that without soil we have used the farming method. This is the case of the hydroponic. In case of hydroponic, without without soil, without moisture, directly we can give the water to the seed. This is the case of hydroponic. But now in this time we have a limited areas in the case of hydroponic, and vertical farming means that it to go the vertical direction, not a horizontal. So this is the case of the conclusion. Just means that with the help of the smart farming, increase productivity with fewer resources, improve ecological stable of future agriculture dependent connected technology. Because in smart farming, we have used the technical method. This is the conclusion. Thank you. Questions and
Thank you so much for that presentation. Do we have any questions? There's a question in the chat box. What specific types of sensors are utilized in this framework, and what exact parameters do they measure to optimize farming operations?
the sensor just means that the name also I have paper in it. In this case, the agriculture in agriculture. In sensors, just sensors, artificial neural network, convolutional neural network. We have used it to detect the disease. My paper is the chili plant disease prediction in the case of the chili plant. So, with the help of the artificial neural network, with the help of the convolutional neural network, we can easily find out the diseases in the plant. So this is the case of the sensors. And second one is the second question. The second part of the question is
Okay, thank you so much. You may stop presenting now. Next, we have Akanksha Pandey with the paper title Trust Score, a purchase verified review system for small businesses. Dear presenter, you may start with your presentation.
Yes, ma'am. Is my screen visible?
Yes, it's visible.
Okay. So good afternoon, everyone. I am Akanksha Pandey, and today I'll be presenting our research paper work that is Trust Score, a purchase verified review system for small businesses. So, basically, nowadays, online reviews play a major role in influencing customers' decisions. However, existing review platforms actually allow anyone to post reviews without even verifying whether they actually purchased the product or not. So, this can result in fake reviews from a lot of people on the platform. So, to solve this problem, we developed Trust Score, where only verified customers can submit reviews through purchase verification. So, the main aim of Trust Score is to create a transparent and reliable platform to for small businesses. So, we verify customers' purchases using OCR-based bill verification, that stands for optical character recognition, which allow only verified people, customers, to submit the reviews. And the system combines structured ratings with multilingual AI-based sentiment analysis to generate a reliable trust score. And we also it also provides analytics like real-time alerts and secure authentication using modern security mechanisms. And we reviewed several recent research papers related to fake review detection, multilingual sentiment analysis, trust scoring, and AI generated feedback. So, existing approaches provide effective solution for individual problems such as sentiment classification or anomaly detection, but they do not
Dear
integrate
presenter,
purchase. Yes, ma'am.
I'm sorry to interrupt, but I think you have stopped sharing.
Oh, uh, we reviewed several recent research papers that are related to fake review detection, multilingual sentiment analysis, trust scoring, and AI-generated feedback. But existing approaches focus on individual problems like sentiment classification or anomaly detection, but they do not integrate purchase verification, multilingual NLP, or hybrid trust score calculation. So this research gap motivated the development of Trust Score as a complete solution. So this is the system architecture of our project. In this, the process begins when a customer registers and logs in using OTP verification and JWT authentication. After purchasing a product, the customers uploads the purchase bill, and the bill is processed using OCR.space, which extracts important information such as shop number or bill ID, and then backend validates these details and checks for duplicate details. Only after successful verification, then only customer is allowed to submit structured rating and textual review. And the review text is then sent to Fast API service where the XLM Roberta, a transformer model, performs multilingual sentiment analysis. And the structured rating and AI sentiment combined using our hybrid trust score algorithm, the updated trust score and analytics alert and report are stored in our database. And for database, we have used MongoDB. Also, in our project, we have focused on security. For it, we have used AES and SHA for confidentiality and data integrity. And this is the proposed methodology, which consists of 6 stages. The first stage is bill-based verification, where OCR validates the uploaded bill and prevents duplicate submissions, ensuring that only genuine purchases can generate reviews. Next is that verified users submit structured ratings along with textual reviews, improving data authenticity. The review is analyzed using multilingual NLP to XLM Roberta to determine sentiment, and the final trust score is then calculated by combining structured rating and AI-generated sentiment, also using a hybrid scoring approach, where the structured rating receives higher weightage for better reliability. And finally, every verified review updates the trust score, generating alerts for strongly negative feedback so that shopkeepers will know if there are any urgent issues and they can work on fixing it. And also, shopkeepers will receive a weekly analytical reports. And for tech stack, we have used Next.js, React, TypeScript, and Tailwind CSS for front end. And for backend, we have used Next.js API routes to handle the application logics. And Fast API manages AI processing because it integrates efficiently with Python-based ML libraries. And MongoDB is used for storing users, bills, reviews, trust scores, and analytics, while Prisma ORM simplifies database operations. We have used MongoDB for flexible database storage, and we have used OCR.space for extracting the bill details. And for multilingual sentiment analysis, we have used XLM Roberta and the and transformer model implemented using Hugging Face, transformers, and PyTorch. And from a security perspective, we have used OTP verification, JWT authentication, bcrypt for securely hashing the password, AES 256 GCM, which encrypts all the sensitive information. SHA 256 ensures data integrity by detecting unauthorized modification. Finally, CATB is used for deployment. OpenStreetMap, Leaflet, and NodeMailer provide map services and email-based OTP delivery. So, advantages of Trust Score is that it prevents fake reviews before they are posted instead of detecting them afterwards. Customers receive more authentic and reliable reviews, while shopkeepers are also benefited from real-time alerts, analytics, and actionable insights that can help them improve their quality. So, overall, the system creates a more transparent and trustworthy review ecosystem. And in conclusion, Trust Score integrates OCR-based purchase verification, multilingual AI sentiment analysis, hybrid trust score calculation, and secure authentication into a unified platform. By ensuring that only verified reviews contribute to business reputation, the system improves review authentication, enhances transparency, and also provides meaningful insights that support better decision making. These are the references that support our research paper. Thank you.
Thank you so much for that presentation. Do we have any questions? Okay. Now, can we have Abhishek Patel for the paper titled Vision Transformer for Maratha Weaponry Recognition, a comparative study of training from scratch versus retained fine tuning.
Hello.
Hello, presenter. You may start presenting.
Yes. Am I audible?
Yes, you're audible.
So I'm sharing my screen.
Okay.
Is my screen visible?
Yes, it's visible.
Uh, Good evening, respected session chair, professors, researchers, and my fellow participant. I'm Abhishek Patil from the Department of IT from ISCOR IT College. Today, I will present our research titled Vision Transformer for a Maratha Weaponry Recognition, a comparative study of a training from a scratch versus pre-trained fine-tuning. So, the historical weapon identification is still performed manually by museum expert and historians, making the process slow and time consuming. Many Maratha weapons also have very similar shapes, making visual classification very challenging. To address this problem, we created a dedicated Maratha weapon dataset, compared three deep learning models, and developed an Android application for a practical weapon recognition. So, for the dataset, we collected weapon images from a museum archives, private collectors, and trusted online sources. After cleaning the data, our dataset contains 1292 images across 10 weapons. These weapons are listed here. All images were resized to 224 by 224 pixels, and several augmentation techniques such as rotation, flipping, color jittering, Gaussian's blur, and a random erasing were applied to improve model generalization. Finally, the dataset was divided into 80% training and 20% testing, resulting in 1032 training and 259 testing images. So the methodology is we compared three different models under identical training settings. The first was a vision transformer trained from a scratch. The second was ResNet 50 pre-trained on a ImageNet. And third was a vision transformer pre-trained on ImageNet 21K. We selected Vision Transformer because of its self-attention, allowing it to capture global shape information instead of only local feature. This is a particularly useful because historical weapons are mainly distinguished by their overall shape and structure rather than the textures. All the models were trained using the Adam optimizer and cross entropy laws to ensure a fair comparison among the all. The system architecture would be the slide shows the workflow how our Android application called Maratha Shastra is work. Uh, the user captures or uploads weapon image which is processed under and passed to the pre-trained vision transformer for a classification. The application then displays the predicted weapon name, confidence score, historical information, and warfare role. Since the entire process runs locally on the device, the no internet connection is required. So I'll show the demo of my app. So this is app, the video is there. So user will just scan the image from the camera as well as they can upload the images. So when we click the image, it will be passed and processed. Then it will show confidence score, the type of then the type of weapon as well as the in which era this weapon is used and the description, a brief description about that weapon. So in the conclusion, so our results are similar. The pre-trained vision transformer achieved the highest accuracy, that is 91.12%, outperforming ResNet 250, which is achieved 84.50%, and vision transformer trained from scratch, which achieved 34.36%. The pre-trained model also coverage much faster and produced the strongest confusion matrix. Most classification errors occurred between Zambia and Khanchir, as both weapons have a very similar curved blade. Then our Android application, to demonstrate real-world usability, we deployed a very best performing model. So I would conclude by saying this work represents the first machine learning study for automatic recognition of Maratha weaponry. We introduced a dedicated data set of 1292 images, compared three deep learning models, and shows that retained vision transformer achieved the best performance with 91.12% accuracy. Beyond its technical performance, this work demonstrates how artificial intelligence can support cultural heritage preservation by assuming museums, historians, and researchers in a faster documentation and a digital catalog of a historical artifacts. We also hope that our data set will encourage further researchers in AI-based heritage preservation. Thank you for your attention. I'll be happy to answer your question.
Thank you so much. Any questions? Okay, no questions. You can stop presenting. Okay, I would like to call Faguni Jha. Are you there in the meeting? Is Jennifer Flores there in the meeting? Okay, with that, we are done with today's presentations. I would sincerely like to thank all our authors for the excellent informative presentations and contribution in this session, and all our participants for being a part of this international conference. I hope this session was informative enough. We, on behalf of the whole team, thank you for the support during this 11th version and all the previous 10 versions of the conference. We will be happy to see you. We will be happy to have you in the 12th version in 2027. All the presenters would be getting their digital certificate through email within 2 working days. The publication will be live within 7 to 8 months. Kindly cooperate with the team of ICT4SD 2026. And I would also like to thank our session chair for chairing this session. A token of appreciation for the chair on behalf of the team of ICT4SD 2026 and Global Knowledge Research Foundation and partners. I kindly request everyone to switch on their cameras for a quick snapshot to capture this digital discussion. Can everyone turn the cameras on? Thank you, everybody. Stay safe and take care.